Previously, we've looked at the definition of a function, and if you have two variables, let's say x and y being the dependent variable and x being the independent variable, the relationship is a function if for every value of x, there's only one value of y, or at most one value of y that maps to it. So we're talking about one-to-one or many-to-one relationships. So that's what I've written up here. So let's introduce some notation to indicate that we're talking about a function when dealing with relationships involving variables. So we'll use x and y in our video here. So let y be some function that depends on x. So y is dependent, x is independent. In other words, y is a function of x, either one-to-one or many-to-one. Okay, so that's described in a previous video. So this relationship can be written in a special form. It's actually in the form y equals an f bracket x close bracket. Okay, so the way we say this, we say that y is f of x. Okay, so that just means y is a function of x. Okay, again, the independent variable goes in the brackets here. The dependent variable sort of goes on the outside and the other side of the equal sign, and it doesn't have to be the letter, the pronumeral y or the variable y, can be anything you want. But again, just for simplicity and just for ease of explanation, I'm just going to use x and y in this example. Now, the value of y depends on the value of x. And I think we've established that in the past. Even when you're not explicitly dealing with functions, when you have an equation, or in the form say y equals something to do with x, let's say y equals x squared, you know that the value of y depends on whatever value of x we set. We're just making it more explicit here. So, for example, if we write y equals f of 2, remember that the value inside the brackets, that's an independent variable. We can set that to whatever we like. Whatever the equation is, or whatever the expression is, when you substitute 2 into it, that'll set the value of y. So this means that the y value is the value of the function when x equals 2. Now this is going to make a bit more sense when we look at an example. So here are some examples here, and I've defined a function. So if f of x, okay, so hopefully you start getting used to saying that when you see this notation. If f of x is equal to x squared minus 3x, find f of 3. You've got f of negative 3, f of a plus 1, and finally f of 1 plus f of 2. So let's do the first one. So I'm just going to move the board over there. Okay, so a, how do we evaluate f of 3? So now f of x really is like the y variable, the dependent variable, sorry. You could actually write it, if you want, as y equals x squared minus 3x. I mean, it kind of means the same thing. So it's not precisely exact. You've got to be mindful here of notation and the way we communicate the idea across. But really what this is just, think of it as the y variable. Here's the x variable. So x-axis, y-axis. Okay, we'll do some more of these examples in subsequent videos, and we'll look at this in a bit more detail. But just for now, we're just going to focus on the notation aspect and the meaning of, so when you have a number inside the brackets, how does it work? In other words, how do we evaluate the function? What we're going to do, we're going to substitute 3 into this function. So f of 3, okay, is equal to, now where you see the x, I'm going to put open bracket, close bracket, squared. So instead of x squared, I'm just going to write 3 squared. Now, for safety's sake, I'm going to sort of encapsulate the 3 in brackets. This is especially important if what you're substituting in is a negative number. But it's good practice to just put it in brackets, whether it's positive or negative, and it's a good habit to get into. Minus 3 outside of, and we're going to substitute 3 again in brackets there. Okay. So what are we going to get there? We'll get 3 squared, so that's 9 minus 9. Okay, and that's equal to 0. Okay. So I'm just putting all the, and it's not good practice, but putting all the equal signs all on one line. I'm just trying to save a bit of space here. Okay, so normally, actually, I might have a little bit of space there. I'll just put it here, make it look a bit neater. Yeah, that's better. Happy with that. Okay, it's better to write it like this. All right. Happy with that. Let's have a look at part B. I might put part B here. F of -3. So you might want to have a go at it yourself. You want to pause the video, have a go at it. What does it evaluate to? What would the dependent variable take on in terms of value? Right, f of -3. Okay, so that means we're going to substitute -3 into the equation. So that's going to be -3 all squared. So notice the importance now of having the brackets. Again, good habits are so important to build, especially when you're in an assessment task, for example. You haven't got time to think about this stuff or with some things. It should be just automatic. Okay, so -3, put it in brackets all squared. You're not going to have a problem with the answer being negative when it should have been positive. And you know that if you square a negative number, it's always going to be positive. -3 outside of -3. Okay, again, good use of brackets there. Make sure we don't make these mistakes. -3 all squared is 9. Now minus -9, so minus -9, and that will be 18. All right, let's have a look at part C. So this is f of a plus 1. So just leave that there. Yep. F of a plus 1. We'll do the same thing. Wherever you see x, we're going to substitute a plus 1 in its place. So that's going to be a plus 1 all squared minus 3 outside of a plus 1. Okay, that's a perfect square. So that'll be a squared plus 2a plus 1 minus 3a minus 3. Okay, collect the like terms. So we've got a squared. You've got positive 2a minus 3a is minus a. And we've got positive 1 minus 3. So that's going to be minus 2 or -2. Okay. And last one. All right. We got f of 1 plus f of 2. Okay. We can evaluate these separately, or just evaluate them all on the same line. So it doesn't matter. As long as you use the brackets wisely, you're not going to make silly mistakes here. All right. So x squared minus 3x, and we're going to substitute 1 in there to work out what the value of the function is. So what I'm going to do, I'm just going to use square brackets. Okay, x squared minus 3x minus 3. Okay. Plus. Now this is especially important. This is why I like to use brackets like this. If the question was a minus sign instead, f of 1 minus f of 2, then the brackets become critical. So again, just a good habit to get into. Plus f of 2. So where I see the x, 2 squared minus 3 outside of 2. Okay. Let's evaluate each of the square brackets. So we have 1 minus 3, okay, plus 4 minus 6, 1 minus 3, that's -2, okay, plus 4 minus 6 is -2, and that will equal -4. And that's how we use function notation. Thank you for watching.